Phase and Energy Balance for Biosystem, Module 4, Foundation of Conservation Principles, Segment 1, Mathematical Framework for Accounting Equations. It's me, Lily from School of Life Sciences and Technology, Institute Technology, Bandung. In this module, we will discuss about the mathematical framework for accounting equation, mathematical framework for conservation equation, also system description and summary of use of accounting and conservation equation. In this segment, we will first discuss about the mathematical framework for accounting equation. Mathematical framework for accounting equations. The accounting equation is a mathematical description of the movement, generation, consumption, and accumulation of extensive property in a system of interest. An accounting equation can be written for extensive properties and the rates of those extensive properties that can be counted. Accounting equation can be represented in three forms: algebraic, differential, and integral. And for algebraic, is applied to extensive properties within a defined system during a defined time period. For the differential, it can be represented as the rate, and rate is defined as the amount of an extensive property change per unit time. And for the integral, it can be used to incorporate rates of change of an extensive property and evaluate condition between the two discrete time points. Algebraic accounting statements. Algebraic accounting equations are generally applied to extensive properties within a defined system during a defined time period. Algebraic equation can be applied when discrete quantities or chunks of extensive property are involved. They cannot be applied when rates or time-dependent terms are involved. And this is the generic algebraic accounting equation can be written as psi in minus psi out plus psi generation minus psi consumption is equal to psi accumulation, where the psi is any extensive property, psi in is input the quantity of extensive property that enters the system during the time period, psi out is output that the quantity of extensive property that leaves the system during the time period, and psi generation is the quantity of extensive property that is generated in the system during the time period, and psi consumption is the quantity of extensive property that is consumed in the system during the time period, and for the psi accumulation is the difference between the quantities of extensive property contained within the system at the end of the time period as compared to those at the beginning. And the initial and final condition can also be used to define accumulation, and it can be written as the psi f minus psi 0 is equal to the psi accumulation, where the psi f is final condition, which is the quantity of extensive property contained in the system at the end of the specific time period, and for the psi 0 is the initial condition, which is the quantity of extensive property contained in the system at the beginning of the specific time period. In differential accounting statement, rate is defined as the amount an extensive property change per unit time or t, and rate is written as delta EP per delta T, where delta EP is the change in the extensive property and delta T is the change in time. The units of these rates are extensive property divided by the time. And the example is a flow rate. A flow rate describes the transport of an extensive property over a period of time. A flow rate can transport an extensive property of interest into and out of a system over time by inlet and outlet stream. The differential form of the accounting statement is most appropriate when extensive properties are specified as rates. And also, a differential equation is often used when the system is operating on an ongoing or continuous basis. And differential accounting statement is written as psi.in minus psi.out plus psi.generation minus psi.consumption is equal to psi.accumulation or d psi over dt, where the psi.in is the rate at which an extensive property enters the system. For the psi.out is the rate at which an extensive property leaves the system, and for the psi.generation is the rate at which an extensive property is generated in the system, and for the psi.consumption is rate at which an extensive property is consumed in the system, and for the psi.accumulation is the rate at which an extensive property accumulates within the system. And here, the table lists the most commonly used extensive properties as amounts and rates. The extensive properties can be seen in the table and also their associated rates. And for the third form, the accounting statement can be written in an integral form. The integral balance are most useful when trying to evaluate condition between two discrete time points. An integral accounting equation can be written to incorporate rate of change of an extensive property. And when developing an integral balance, we can write the differential balance equation and integrate it between the initial and final times. And the integral accounting statement is integral from t0 to tf psi.in dt minus integral from t0 to tf psi out dt plus integral from t0 to tf psi.generation dt minus integral from t0 to tf psi.consumption dt is equal to the integral from t0 to tf psi.accumulation dt, where the psi.in dt is the total extensive property that enters the system between the initial time t0 and final time tf. And for the integral psi.out is the total extensive property that leaves the system between t0 and tf. And for the psi.generation is the total extensive property that is generated in the system between t0 and tf. And for the integral of the psi.consumption dt is the total extensive property that is consumed in the system between t0 and tf. And for the integral of the psi.accumulation dt is the total extensive property that accumulates in the system between t0 and tf. For the next segment, we will discuss about the mathematical framework for conservation equations. Until then, I'm Lily from Institute Technology Bandung.